glass will also have molecules. So if you look at the why the free surface, and this layer is a free surface. I think I'll draw the look at the free surface how it is. It is spherical, no? Why do it is in curved shape? This is what we are trying to explain now. So now let's consider the molecule 1. Okay, this is a free surface. No. Look at the molecule 1. So it will experience an force, adhesive force. So we'll exit, the glass will exit on the molecule. The glass molecule which is present will exert force on this one. Similarly, this adjacent molecules which are there, cohesive force will exert, no? What do you mean by cohesive? What do you mean by adhesive? Force of attraction between molecules of different kind, glass molecule and the water molecule. The interaction is, that is adhesive force. These adjacent molecules will exert force. That is a cohesive force. And how do it act? The cohesive force will act in this direction. The cohesive force will act. And what will happen is the adhesive force will dominate over cohesive force. Shall I take symbols? Okay, FA, this one. So the adhesive force dominates over cohesive force. So because of that, the resultant force, what happen, will be directed. I need some other color. Yeah, the resultant force will be somewhere like this. Now we have to ask questions. Why free surface here like that? You know what is the property of free surface? It will always align itself perpendicular to net force. Will I agree? Since FA greater than FC, so definitely what will happen? The resultant force will be more towards FA. So therefore, the force what happen will subtend lesser angle with the adhesive force than cohesive force. What about this? Why free surface horizontal? Like suppose let's take this particular molecule. The adhesive force will be equal and opposite, and the net force will be downward. And the net force is downward. So therefore, the free surface here will align itself like this here. And what about here free surface? The net force here will be like this, and the net force here will be like this, and the net force will be like this here. This is what the resultant of cohesive and adhesive force will act, and based on that, what happens? The net force will act perpendicular to net force. The free surface will align. You know. So now this particular there's a free surface. There's everything is water, no? There's everything is a water. So here I'll bring angle of contact. This is what the angle of contact here. So this we know it's a free surface. And there's a water, it's a liquid, no? And there's a solid. And how do we measure angle of contact? From the solid here. And how the force due to surface tension will act, anybody? By the liquid on the glass will be downward. By the glass on the free surface will be upward. Because the pull force, no? If there's a molecule like this, there's a molecule of glass molecule. There's a water molecule. Here we are taking this one. So glass in what direction will exert a force? Glass will exert force in this direction. Water molecule will exert force on the glass in this direction. Tangential, it should be. And this will be a little bit student must have a clarity here. What is this arrow? Red color arrow. Force exerted by the glass molecule on the water molecule. And what is this green color? Force exerted by the water molecule on the glass molecule. So I'm interested in this. I'm showing like this here. And what about red color? Red color arrow you have to show in this way. And tell me like, what is this F and this F? Force by the glass on the water molecule. And what about this? Force by the water molecule on the glass. And it's like here. So everywhere I think it's not a plain diagram. Try to imagine. So what do you get? You get this is like a curved surface, no? Like a cup it will come. Like a cup it will come. So if you draw the free surface, how the free surface will be like this. This will be air. Below this will be liquid everywhere. Tell me how the force we have to show it. The force you have to show it in this way. Not at one point, at everywhere. Able to make it out? This will be the what happened? The glass will exert a force. Now this theta I'll call angle of contact. Look at it is, shall we call acute? So how to define angle of contact? It is the angle made by the tangent drawn inside the liquid with the solid. It's the angle measured between the tangent drawn inside the liquid and solid. This should not be the angle of contact. Inside the liquid will measure. This is the liquid, no? Inside the liquid it should be measured. Here there's the air. The liquid is here. So this is the angle of contact here. And now same thing instead of this. So what is this? Now you can ask questions. So what are these vertical? This is a glass pipe. What is this? This is a glass pipe or capillary tube. Glass pipe. It will be like this. Fine. The water will rise here, no? Capillary glass pipe. Capillary glass tube. Straw. All of you seen straw? If the straw made up of glass and you dip in water, you can see the water surface will be of this shape. And now same thing if I place water drop on a glass surface, then how do the water drop will align? The water drop will align like this. The central idea is adhesive force will dominate over cohesive force. And now if I show the molecules will be of like this. Black color. There's a free surface. No? The molecules. Many will be there for understanding purpose. I'm showing few. That is a nature ma. Why Fa greater than Fc? That is what nature's adhesive force is greater than cohesive force. Why it is not possible? There's a nature's phenomena. Okay, there's a water drop. This I think you can clearly experience. There's a glass plate. Clean glass plate it is. Now look at this one. Why the liquid drop and what is the angle of contact? The angle of contact is what? Here, what are the things, you know, the net force, how it is? We are sure the net force is acting somewhere like this. Then what are the cohesive forces? The cohesive force, net force, brown color. How the adhesive force between on this molecule will be in this direction, and the cohesive force somewhere like this. Which force will be greater here? So again, if we go for this adhesive, and this is a cohesive. So here again, I can see that Fa greater than Fc. So the net force, resultant force will be somewhere will be directed, and the free surface will align itself perpendicular to net force here. Why the here the free surface horizontal? Because the net force will be downward. And I'm showing few, so you must be able to understand here. There's a thing. So what is the angle of contact here? So the angle of contact here will be glass plate. So this was the free surface. No. So what is the angle of contact? This should be the angle of contact. Okay, fine, agreed. And how the force, the force will be exerted here? So what is this? Shall we go for some drawing? How the force due to surface should act tangentially? The force due to surface tension should act tangentially. So this is the direction of F will show like this. Now tell me, like, what is this F? Force exerted by the water drop on the glass plate. By the glass on the water drop should be opposite to this. Already I written, no? Water drop, yeah. Fine, agreed. This one. So why shall we say that water drop will wet the glass plate? Are you see it is spreading? So what is the conclusion we can make it? Water drop wets the glass plate. Wets I'm using. And what is the angle of contact? Angle of contact is obtuse. Angle of contact will be acute. Why water will spread? Water will what happen? Water will wet wood. Am I right? Water will wet glass. Water will wet cloth. Water will wet paper. The reason the theta will be less than 90 degrees. Glass plate. Okay, similarly, we'll go for now if I place a mercury in a capillary tube, the shape will be so this will be some rough shape I'm showing. Now how the molecules here. The theory imagination is very important. Once you get this clarity, I think you can manage very easily the numericals. Huh? No, here cohesive force will dominate the adhesive force here. So how the adhesive force? The adhesive force will be in this direction. The adhesive force will be in this direction. And what about the cohesive force? The cohesive force will be somewhere in this direction. And the resultant force will act near to the net force. So here what will happen? FC. Okay, that's fine. There's a nature's phenomena. What about this molecule? How the net force will be downward? It will be here. It will be here. Okay, there's a reason why the mercury surface will be like this. And what is this? What we have? Glass capillary tube. And what is this? Mercury. And this is air. Okay, fine. So now we'll show the angle of contact. This is the angle of contact. Now here we were showing forces, no? The mercury will exert force on the glass like this. And in turn, the glass will exert force on the mercury in this direction. And what is the angle of contact? We define this is the angle of contact. Try to see the arrow. This is the mercury. This is the air. This is the glass. Look at the angle of contact. So how you define angle of contact? The angle measured between the tangent drawn inside the liquid and the solid. So this is not angle of contact here. There's a solid surface. So what is this? This is a liquid, no? And there's a solid. So it is defined, no? The angle drawn, the angle subtended by the tangent drawn inside the liquid between the solid and liquid surface, or you can put like this: the angle measured between the tangent drawn inside the liquid between the solid and liquid surface. That is the angle of contact. This is not angle of contact. So what is the angle of contact for mercury glass? Will be obtuse, more than 90 degrees. And what is this F? Force exerted by the mercury on the glass. By the glass on the mercury will be like this here. Now, what about here? Here you should draw like this, tangential, because everywhere the force will be tangential. Newton's third law, action reaction, equal and opposite. This molecule exert force, this molecule. But sir, here you are shown, I'm showing the only the resultant force on the free surface and not on molecule here. Not on molecule, that one, on this one. So if you look at the free surface of mercury, if you draw it, how the force will be. There's a free surface will come like this. Then how the force, the green color arrow you have to show everywhere downward. Able to get this one? Okay, that's what the basic conditions it will arise. So now let me place this mercury drop on a flat glass plate. How the mercury will take shape like this. It will not wet. Okay, able to understand. So this everything is mercury, and I'm showing only free surface. Then the molecules you have to show like this. These are the molecules. Tell me, what is the angle of contact? Did the glass plate? Did the mercury drop? And what is this? Did the free surface? And then this is the angle of contact. Okay, here also if you want, you can show this one. This will be say like an adhesive force. With this one, and the resultant cohesive force will act somewhere like this. And the resultant force will act in this direction. Then we'll just show the angle of contact clearly here. It will not wet much. I think I didn't draw properly. Show like this. So it will not wet. So what is the angle of contact here? So this should be the angle of contact. No, some arrows I'm showing it. Can you show the tangent, the force due to surface should act tangentially? Tell me what is this force? Force exerted by the mercury on the glass. By the glass on the mercury drop will be in this direction. Because the force due to surface should act tangentially, and this is the theta. So what is this F I should call? Fine. No. Mercury will it wet glass plate? No. Mercury will not wet the glass plate. So, so why some liquids will wet, why some liquids will not wet? This is the thing. Similarly, now you can take many other things like this one. Why the water will wet the surface? It all depends upon the angle of contact. It all